Okay? So these quick review problems, these second two look like they're the same, but we're going to handle them differently. This one right here, we're going to do without a calculator. This one, we're going to use a calculator for. So both of these questions can be on the test, but they'll be on different parts. What is special about 9 and 27? They are not just random numbers. What's special about them? Okay, so they have a common base. 9 is 3 squared, and 27 is 3 cubed. So they can both be written as powers of 3. So the same relationship would exist between, let's say, 4 and 8, because 4 and 8 are both powers of 2. Once you have changed 9 into 3 squared, and you change 27 into 3 cubed, since these are both 3's, you can set the exponents equal to each other, and x equals 3 halves.
You gotta stop eating like this.
I know. Normally me for review asking for
Okay? Now, you look at this review problem. This is a whole different situation, because you can still make 9 3 squared. You can still do that. But can you do that with 21? Can you make 21 3 to something? No. So that procedure, that method, isn't going to work. We're going to need to use our calculators. I got to get that down. How do I bring an exponent down? There's only one way to do that. How do I get an exponent down?
Add log.
Yep, I got to take the logarithm of both sides. And somebody earlier today said, Mrs. Ford, how come sometimes you LOG and sometimes you LN? Who can answer that question? When do I want? Go ahead.
It's an E.
Exactly. If you got an E, absolutely LN. If you don't, then go ahead and use log if you want. Can you use LN? Absolutely, but it doesn't help anything. So the minute I do that, my exponent is going to come out in front. So x comes out in front. So x log 9 equals log 21. And then what will I end up typing into my calculator? How am I going to figure out what x is? Log 21 divided by log 9? Right? Because I'm going to divide both sides by log 9. So log 21, close parentheses, divided by log 9. 1.3856. 1.3856. Does anyone have a question about any of those review problems? Do you see the difference between these two? Yeah. If I put it on the no calculator part of the test, you will always be able to make a match here. So whatever these numbers are, you'll be able to break them down and get a common base. Because that's the only way to do it without a calculator. All right, group, let's get our notes back out. We're going to finish up 3.5 today. So that means this homework is going to be due on Monday. I'm not sure, I may have the wrong date in Power School. I'll have to fix it. This homework will be due Monday, 3.5, because we're going to finish it here. We also have Flex today and tomorrow, so you're welcome to check back in at 2:05 if you want. Either day, both days, today and tomorrow. Okay, so we are ready for, on page 29, the back, we're ready for letter C. And this is almost identical to the last problem we did yesterday. So it's really great that we're practicing again because that problem was a little bit tricky. All right, but here we are on letter C. Can you look at letter B, or can you remember? What do we do?
Have to combine them.
Yes, you got to put them together. You can't have this. This is not allowed. So we're going to put them together into one. And when I put them together into one, I have to put the x and the x plus 3 together in here. So what do I do with them? Do I add them, subtract them, multiply and divide them? What do I do with those?
Multiply.
Exactly. Because that's an add. You're always either going to add or multiply them or divide them, because they're always going to have an add or a subtract. If it's an add, we multiply them together. We'll do a subtraction problem here soon, and we divide them then. So we've got.
Then you do log 10x squared plus 3x equals 1.
That's exactly right. Mary Kate snuck in something there on you. She said log base 10. I hope everybody recognizes that log means base 10.
And then wouldn't you, it'd be like 10 to the first
Yep.
power?
Yep, she's gonna loop-de-loo.
And then you have to set it up like a quadratic.
So we know 10 to the first is 10. And we talked about this yesterday, or whatever day I saw you before. Remember that quadratics have to be set equal to 0. So I'm going to subtract the 10 over. Now, what do I do?
Now it's x plus 5, x minus 2.
So she's factoring, and we talked about that if you don't want to factor, what could you do instead if you didn't want to factor?
Quadratic formula.
Yeah, you could absolutely use the quadratic formula.
Mrs. Ford,
Yes,
when you get your answers, can't the -5 not be an answer?
exactly. You're way ahead of us, Ella. Good work. She says, when I solve these now, x is going to be -5 or x is going to be 2. But that one's extraneous, because back in the original problem, if I let x be -5, I'd have to take the log of a negative, and that is never allowed. That gives you an error message. So that answer simply won't work. It's extraneous, and the only answer to the problem is 2. Does that look familiar from yesterday? Sort of? Yeah, it's real similar. Put a big X through D. D is a horrific problem. I don't want to mess with D. I made a mistake when I wrote it, so we're just going to get rid of it. So just cross out D, and let's go down to E. All right.
Did you put a foil here?
Well, not yet. First, we're going to eventually have to foil, yes. But I want to ask Chase. Chase, you with us?
Of course.
Okay, what am I going to do first? Take a look at the problem. It's very similar to the one we just did. This is a problem, Chase. We can't have two of these. So we're going to put them together into one. There's going to be one logarithm now. What's going to go in that box?
Would it be x squared plus 16?
Well, you're very, very close. You did the right thing. You just have one little mistake in there. It's x plus 4 times x minus 4. And then like Mary Kate and Chase both said, we're going to have to FOIL. But when I FOIL that out, I actually get x squared minus 16. But you were doing exactly the right thing, Chase. And Mary Kate, you had it nailed too at the beginning. Okay? William, I'm not sure what's going on. There's a lot of movement in that screen. Can you tell me what the next step would be? William?
Would you factor? Would you add the 16?
Well, okay, let's talk about that. First of all, if I factored, it would actually back me up to a step I've already done. So I don't want to do that. And I can't add the 16 because I can't take a number out of the parentheses. So there's really nothing to do here except get rid of the logarithm. How do I get rid of the logarithm? What process do I use?
Loop-de-loop.
Yes, loop-de-loop.
Loop-de-loop.
So it's going to be 5 to the second equals x squared minus 16. So 25 equals x squared minus 16. Add 16, so 41 equals x squared. And technically, x equals plus or minus root 41, but you can't have the negative. That would be extraneous right here. So the answer is just the square root of 41. That's a lot to process. Who has a question about it? William, I need you, and everybody, I'll speak to you particularly, I need you to remember that when you get down to where you have just your logarithm equal to something, you have to loop-de-loop, because the only way to get rid of that is the loop-de-loop, and you have to get rid of it to solve it. Okay? So to get rid of your logarithm, loop-de-loop. All right, F. And F ran off the page. So I'm just going to make something up for the end of it and hope for the best. So I'm going to say log base 3 of x plus log base 3 of 4 equals log base 3 of x minus 1. Wow, this has a lot of logarithms in it. This one doesn't bother me because the rule says I can have one on each side. This bothers me because there's two on the same side. Jada? Can you put these two together for me? What would this be if I put these two right here on the left side? If I put them together, what would that be?
X plus 4.
Okay, that's a good guess, and a lot of people are going to do that. The rule, though, Jada, says that when they're added, when the logarithms are added, when you squish it together, it becomes a multiply. Always. When you turn 2 into 1, it becomes a multiply if these were added. Now, I just got done telling William that when you want to get rid of logarithms, you loop-de-loop. But this is a little bit different situation because why? What's different about this situation?
There's another log.
They're on both sides, okay? That actually makes it easier. When they're on both sides, they cancel out. When you have a logarithm on both sides, they cancel out. So we have 4x equals x minus 1. Because I got one of these on each side gone. So now I'll subtract x and divide. I got negative 1/3. Did you? Did you get negative 1/3? Is that going to work? Can I put a negative 1/3 into my problem? No. Gabe's shaking his head violently back and forth. No. We have no answers here. That's an extraneous root. That's an extraneous root. Remember that this guy right here can never, ever, ever be negative. So if we'd gotten positive 1/3, all good. But it can't ever be a negative. Okay, Jada, I want you to look carefully at this one. It's a little bit different. We have the same problem. These have got to go together. So you can't have these two on the same side. They've got to go together. But this time, Jada and everybody else, this is a minus. So when I put them together, what's going to happen?
Division.
Exactly. This is going to be 2x divided by 3. If you have 2 on the same side, you always have to put them together. If the 2 are being added, then you put them together with a multiply. If the 2 are being subtracted, you put them together with a division. Now, are we going to loop-de-loop? No, because we've got a logarithm on both sides. So 2x over 3 equals 5.
I might have done it wrong, but I got 215.
Would you multiply the 5?
You multiply the 3?
That's what I meant.
Yeah, so 2x equals 15. And then divide by 2. So actually, it's 15 halves. Mary Kate, did you just write it down wrong, or what happened there?
Yeah, I do that every time.
So many times, Mary Kate, if we try to do it in our head, we screw it up. So it's better just to go ahead and write it down. Divided by 2, divided by 2, so that you can see it right there. Now, that's a fraction. Is there anything wrong with it? No, because it's not negative, right? All right, there's one left. I want you to try it on your own. We've just done a couple of examples just like it. So see what kind of progress you can make on problem H. Anybody getting an answer yet?
I got 3/12.
1/4. We reduce it.
Oh.
Anybody get anything different? Caroline, did you match Mary Kate? Did you? Good, because she's got the right answer. Let's walk through it. Let's walk through it. Caroline, would you help us? Tell us what you did first.
So first I combined the 3 and the x, so I did 3 over x.
Exactly. So you still have your log, but you only have 1 now. You have log base 13 of 3 over x. Perfect. Remember, you're taking 2 logs and squishing them into 1. So you still have a logarithm. All right, then what did you do, Caroline?
And then I took out, I crossed out the log 13 on both sides.
So you had this.
And I equaled those together and I multiplied the x. And then I divided 12.
You did an amazing job, and I love your steps you went through there. Sometimes people try to shortcut, but you did every step and you did it perfectly. Good, good, good work. So then she divided by 12. And there's where Mary Kate got 3/12, which we'll just reduce to 1/4. Beautiful. We are going to switch gears here in a second, so this is your opportunity. What about that didn't make sense, or what are you a little bit unsure about? Who else got 1/4 besides the 2 girls? Anybody else? Oh, Cammie did. Very good. Katie, awesome. Claire? If you did not get 1/4, do you have a question? Chase, turn your camera back on. All right, guys, we're switching gears. 3.5 due Monday. Need help? Flex will be here today and tomorrow at 2:05. Now we're moving on to 3.6, which is some word problems that I think you will find very, very interesting. But the first thing I need you to do, if you have your note sheet for 3.6, there's some space up here at the top. I need you to write down 2 formulas. These are the 2 formulas that we are going to be using as we go through all of these word problems. And these are not made up word problems. I mean, yes, they're made up, but they're real life scenarios. These are things that you might really want to know someday. All right, so here we go. Here are our 2 formulas. We're going to write at the top. Do not be frightened of them. We're going to talk about what each letter stands for and when we use which formula. Okay, so I'll pause for a second. You make sure you have those copied down correctly, and then I'm going to go through and tell you what all of it stands for. Because even if I give you the formulas, and usually kids have them memorized, but even if I give you the formulas, you can't use them unless you know what all these letters stand for. All right, so here we go. A, I'm looking at this formula right here. A stands for the end amount. This is what we end up with. So, for example, you put some money in the bank and you come back 10 years later. This would be the end amount that you had in the bank. P is the starting amount. So if you took $100 down to the bank and said, here you go, deposit this in my account, that's your P. This is a 1. It's an actual number 1, so it doesn't stand for anything. It's the number 1. R is the interest rate. And make a note, it has to go into the formula as a decimal. So in most of your problems, it's going to say, you know, you have a 3% interest rate. Well, you got to put that in as 0.03. N is the same number in both spots. You don't put a 3 here and a 6 here or something. Whatever N is, that's what it is, and it goes here in both spots. N is the number of times per year that we compound. Now, what does that mean? Tell me you all have bank accounts. Please tell me you have a bank account. Periodically, you get a bank statement and you have earned some interest on that account. If you get a bank statement monthly, that means your interest is compounded monthly, and your N would be 12. 12 months in a year. If you have an account that you get statements quarterly, that means 4 times a year, so your N would be 4. Some accounts compound daily, so that N would be 365. N is how many times a year they compound your interest. And T is the number of years. T is the number of years. I'm going to add an additional note for N here. Monthly means N is 12. Quarterly means N is 4. And annually means N is 1. Those are the most common ones. You can have lots and lots of others, but those are the most common ones because it's the number of times per year. 12 months in a year, 4 quarters in a year, 1 year. This is the formula that you will use anytime the problem talks about compound interest. Anytime you hear compound interest, that's what you're going to use, that formula. Now, this formula is used when you are compounding continuously. So this word's going to be there. The word continuously is going to be there. Or it's going to be a problem from nature. So it'll be a population. Or it'll be a radioactive decay. It will be some kind of biology type problem. Or it will actually say compounded continuously. The word continuously. If it's there, you're using this formula. If it's a biology problem, you're using this formula. A stands for the same thing. P stands for the same thing. This is E, the base of the natural logarithms. That's Euler's constant. It's not a variable. You don't plug anything in for it. It is just E. And if you don't already know how to get it on your calculator, I'll show you when we get to that example. R is the growth rate. So it's like the same thing as an interest rate, and it goes in as a decimal. And T is time. In the compound formula, T will always be years. In the PERT, we call this the PERT formula, P-E-R-T. In the PERT formula, time can be whatever. Minutes, hours, decades, whatever. You'll know when you read the problem. Okay, I'm going to erase all this, Does anyone have a question about that?
What's E?
E is Euler's constant. It is a constant,
Oh.
just like pi.
Miss Ford, this is just on a piece of loose leaf.
Pardon me?
Is this on a piece of loose leaf?
I know, we're getting ready to start page 30.
Okay.
You're way late. I'm not sure where you've been. We're getting ready to start page 30. So we are writing the formulas at the top of the page. These are the formulas we're going to use. So, first thing you have to do when you read problem number 1 is decide which formula you're going to use. There are lots of formulas. You are required to use just these 2. So here we go. Read the problem, number 1, and tell me whether we should use the PERT formula or the big long formula. Which one do you think for problem number 1? The big long one, you're right. And the key word, guys, if you're confused, the key word in the problem is compounded quarterly. When it says compounded quarterly, daily, yearly, monthly, that is this formula. So now we got to start plugging stuff in. Tell me what goes where. Do you have a thought?
1,000 goes in for P.
Yes, 1,000 goes in for P because P stands for what I start with. And I am starting with $1,000. Perfect.
Would R be 0.25?
It would be 0.025. Yes, R is 0.025. Remember, percentages, you have to move the decimal 2 places. So a 2.5%.
And then wouldn't it be 4?
It would be. And that 4 happens twice. It happens here and it happens here. There's an N in both spots. N is the number of times, quarterly, 4 times. Now I'm missing an A and I'm missing a T. I have to know one of those to do the problem. Which one do I know? Do I know my ending amount or do I know my time?
Ending amount would be 2,000.
Very, very good. We know the ending amount is 2,000 because the problem tells me I'm doubling, right? And T is how long is it going to take? That's the question. What's T?
1?
Oh, I don't know. We have to work it out. We have to work it out. I don't think it's 1. Yeah, that's a T up there. So my exponent is 4T.
Couldn't you subtract 1,000?
You don't subtract it, but you get rid of it. How would I get rid of it? This is a multiply here.
Oh, you divide.
You divide. Yep. So we're going to divide by 1,000. Yep. That's exactly right. So we have 2 equal to 1 plus 0.025 over 4 to the 4t. Now, gang, just for kicks, let's see if we can simplify this without rounding it off. I don't want to round it off. I just want to simplify it. Let me see. 1 plus 0.025 divided by 4. Oh, yeah. So I'm going to rewrite that as 1.00625 to the 4t. That just looks a little bit less scary. This looks pretty scary. That looks a little less scary. Okay. Now what?
Do you have to add a log?
Yes! Beautiful! You're making my day. That's exactly what I have to do. Because, kids, your variable is up here in the exponent spot, and you can't figure it out. You got to put a logarithm in so you can pull that exponent off out in front. Very, very good. It's like the review problem we did, only the numbers are messier. Very good. When your variable is an exponent, you're going to use logs. Now, this is what I am solving for. Would you agree with me? So I got to divide by 4. So log 2 divided by 4 equals t log 1.00625. So I'm going to divide off the 4. I'm going to take my calculator. I'm going to have log 2, close parentheses, divided by 4. Now, that's a decimal. Don't write it down. You got it on your calculator. Does it say 0.07 something? Everybody should be typing this in with me, kids. You need to know how to do this, all right? So I divided by the 4. That got rid of that. Now what do I need to divide by? Don't I need to divide by this? So take the answer on your calculator. Take your calculator and just hit divided by log 1.00625. And the answer I came up with is 27.81 years. It's going to take 27.81 years for you to double your money at a 2.5% interest rate, compounded quarterly. You get it? All right, before I erase my formula, let's read the next problem in case I need this formula again. Read problem 2. Am I going to need my other formula, or will I use this one again? Yep, I'm going to use the same one. And I know I'm going to use the same one because why? What does the problem say?
Compounded monthly.
Yep, compounded monthly. Compounded monthly. That's this formula again. So let's start plugging stuff in. Tell me, what can I plug in? What goes where? Where does the 1,230 go? Yep. So 1, 2.
T for T?
Yeah. Yep. So T is going to be 10. Okay. Yep. Because it says 10 years. Very good. So do I have something for R and N? Do I have an R?
Yes, it's 0.03125.
Perfect. The interest rate goes in as a decimal, and that's perfect, 0.03125. Now, what's my N this time? We're compounded monthly. Yep, so it's a 12. And you put a 12 in both spots.
Does that say 12 times 10?
It does, because my exponent is N times T. And N is 12 and T is 10. Now, I would right off the bat go ahead and make that 120, because we know 12 times 10 is 120. What's A?
2,460.
Does the problem say I'm doubling my money this time?
No.
No,
No.
it doesn't.
It doesn't. In fact, what does the problem want to know?
What
Is
age?
it 10 years?
It wants to know how much I'm going to end up with, right? Doesn't it want to know the amount I want to end up with?
Yeah.
Yep. Now, I want you to look carefully at this problem. Are you going to need logarithms to solve it? No. Why not?
You can just plug it into your calculator.
Exactly. You just plug it in. Kids, logarithms are necessary when your variable is up here. If your variable isn't up there, then you're going to plug it right in. And if you plug it in exactly the way I wrote it, you will be all set. So here we go. 1230 parentheses 1 plus 0.03125 divided by 12 close parentheses raised to the 120. And remember, the raised.
How did you do the raise to 120?
You hit this button right here. This is the raised button.
Where?
It is right under the clear button.
Oh, okay.
You raise it to 120 and hit enter. And you would have A equal to $1,680.53. It is really important, gang, that you're typing it in with us.
I have a question about the next one.
Well, okay, we're not there yet. Hang on. So if you're not practicing with a calculator today, please make sure you have one for next time, guys. Okay. All right, one more problem and we're done for the day. How long will it take for a population of 450 geosites, that's a made-up organism, to double if their growth constant is 0.123? Which formula do you think I'll use?
The other one.
Yeah, gotta use per. This is a nature problem. This is a biology problem. We're counting organisms in a petri dish. This is biology, and if it's biology, we're using this formula. I am starting with 450. P is how many you start with. Remember, E is not a variable. E is just E. You don't plug anything in for it. It's just E. The growth constant is 0.123. Notice it's already a decimal for me. It's not a percent. It's a decimal. How long will it take? So that's my T. What's the A?
900.
900. And we know it's 900 because once again, we're doubling. There you go. You've seen this kind of equation before. How do we solve it? What do we have to do first? There's something that has to happen first. What is it?
Would it be a log or LN?
We're going to LN, but we got to do something first. What do we need to do first?
Subtract 450.
Okay, not subtract though.
Or divide.
Yeah, this is a times. So we're going to divide by 450. And that's going to give me 2 equals e to the 0.123t. Now we're going to ln. That's going to cancel. So we have ln2 equals 0.123t. So we'll just divide ln2 by 0.123, and that'll be our t. Now, don't check out. I gotta talk to you about one more thing real quick to make sure you see what's going on. Let's get an answer here. Did you get 5.6353?
I did.
And that's a time, so let's put a unit on it. There's no unit mentioned in the problem, so I'm just gonna say years. These are word problems, so always want to label your answers. Now, I want to go back to something I think it was Ari said. She recognized, we were back here at this step of the problem, and she recognized that we were going to need an ln, and she was exactly right. Look what happens, kids. If you ln at this point, what doesn't happen over here that you really want to happen?
They're canceled.
They don't cancel. So that, maybe that will help you remember that you got to get rid of this 450 so that when you ln, the e goes away. Does that make sense? You don't want to have that 450 left in there because it's not going to work when you ln both sides. You guys did great today. We made great progress. Good job. I don't see you tomorrow, so I will see you either in Flex today or tomorrow or on Monday. Have a great time. Bye-bye. Thanks for coming in.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Miss Ford, is there flex today?
There is. Gonna start in about 5 minutes after I get my attendance in.